Okay, great. So let's continue with the session 5G core deep dive. And in this discussion, what we are going to talk about, right? So we will start our discussion. One second. We'll start our discussion about the evolution from EPC to the 5G core. We will understand what are the things, how we changed from EPC to 5G core, and what are the changes we did in the network architecture, network functions, and things related to that. We will be having a brief introduction about service-based architecture protocol stack and the interfaces around it. And in addition to that, we will also talk about N1, N2, N3, N4 interfaces and the protocols related to those interfaces. And then we will talk about UE registration and PDU session establishment, right? So this is going to be the agenda for this discussion. And let me just see. Yep. Okay. Great. Let me stop my video to save bandwidth for everyone. Okay, right. So this is going to be the agenda for the session today, right? And let us continue with the discussion. And before we really start with the discussion, let me just briefly talk about Telcolan. Telcolan is a leading telecom training and consulting company. We are a member of Bharat 6G Alliance Voice Consortium Telecom Center of Excellence, and we are a recognized startup as well as part of Microsoft Startup Founders Club, right? Just a quick introduction about myself. I come with around 24 years of experience. This is little old data with around 18 and 19 years of training experience, worked with variety of different organizations, system integrators, OEM, service providers, worked with almost all the technologies starting from the wireline network to 2G, 3G, 4G, 5G, transmission, both optical transmission, microwave circuit core, packet core, and worked with variety of different products which include Samsung, Nokia, Ericsson, ZTE, Cisco, etc. Right. These are the various companies I have trained in different capacities. I worked with multiple companies, and in different capacities I have trained in variety of these companies, and these are different colleges and universities where I've delivered these kind of training program. Right. Now, you can also reach out to me on LinkedIn. If you're not connected to me already on LinkedIn, you can connect to me on LinkedIn as well. We also have a YouTube channel at Telcol, and if you search for, there are a lot of useful videos we keep on posting on that, and we also have a Telegram community with the name of Learn 5G. Right. Just to talk about the course, what we are talking in this particular discussion is around 5G core network deep dive. But in addition to that, we offer a lot of different courses to the corporates. So these are basically the customized courses we do for our customers, which are looking for customized courses just for their internal teams. So those courses may start from one day and they go up to 1 or 2 months, kind of 8 to 16 weeks kind of programs as well. So we do variety of different training programs, and if you need to, want to train your teams specifically on some specific topic related to 5G, telco, cloud, AI, ML, feel free to reach out to us at info@telcolearn.com. Right. Now, just a quick note, this is an open session. We may not get into deep tech concepts, what we typically cover in our course, right? So I have already muted you, so you will not be able to unmute. We will be having a question and answer session during the when we are approaching to the end of the session. Meanwhile, if you have any questions, please type your questions in the chat box. We are recording this session and we will be uploading this on YouTube, and we will be sharing the link, right? And then if you have any other additional questions, please feel free to write to info@telcolan.com or visit our website, which is telcolan.com. Right. Now, let us get started with EPC to 5G transition. Now, even before I get started, if you, one second, just give me a second. Okay, if you have any idea about what are the changes happens when we move from EPC to 5GC, can you please write that in the chat box? What are the major differences when we move from EPC to the 5GC? So one second, people are saying they're not able to hear me. Give me a minute. This is a problem which I normally face. One second, I think, let me correct it. Zoom actually reduces my voice sometimes. Sound settings. Okay. Is it better now? Can you please quickly confirm? Is it better? Okay, great. So I think this is some problem with the Zoom. It automatically reduces my voice sound. Right. Now we see that when we move from EPC to the 5G core network, there are some major changes what we are doing in terms of protocols. In terms of protocols, we are moving towards more open protocols. We change few things related to architectures. We change related to things moving from network elements to network functions. But we should also need to know that many of these things has not happened overnight. So even before we started implementing these things in 5G, many of these things were tried and tested in the 4G network as well. For example, the EPC also evolved into virtual EPC, where we can also deploy our evolved packet core into the virtualized evolved packet core. We also had architectures like cups, which is control plane and user plane separation, right? Where we have separated the control plane and user plane of HGW and PGW, right? So there are many things which has happened. But now if we look at the, one second, just so many different interruptions, right? Now, if you look at this architecture where we have this E node B is evolved node B, connecting towards the MME for the control plane, connecting towards the HGW for the user plane. The HSS takes care of the data. PGW is more of a PDN gateway, and the PCRF, which is typically taking care of policy and charging rule function. Now, what are the different limitation it has? If you look at the core network of 5G, 4G, and specifically from the control plane perspective, the MME have multiple different protocols. So it have SGS AP towards MSCVLR, diameter towards HSS, GTPC towards HGW, S1 AP towards eNode B. However, this is something which still doesn't change. More or less, it will transform into a new protocol called as NGAP. But all other protocols, whatever we are using here in the core network control plane, the control plane of the core network, are going to move towards more open protocols like HTTP2. So we will be moving towards HTTP2 kind of protocol, HTTP2 kind of protocol. The other limitation was our core network were having very limited third party access. So they were not really providing standard APIs or open API to the third party integration. However, at a later stage in release 12, release 13, we introduced a new network function in 4G called as SEEF, which is called as service capability exposure function, which can expose the capability of the network to the third party, but it was not really deployed at a vast scale, right? A big scale. So it was just more or less related to some use cases of IoT. However, in 5G, we are building a new network function called as NEF, or network exposure function, which does the magic, where it can provide a lot of integration to the third party vendors as well. The gateway selection was very inflexible in case of 4G, where a user can use one HGW but two different PGWs, right? Two different PGWs. But you cannot choose two different HGW and two different PGW. However, we kind of sorted this out when we were moving towards cups kind of architecture, where we did some kind of control plane and user plane separation for our HGW and PGW, HGW and PGW. But again, it was not really that great in terms of gateway selection flexibility in case of 4G network. And the last but not the least, all the architectures till 4G were hardware-based architecture, where we have a purpose-built hardware with the integrated monolithic software into the architecture, and that's how it actually looks like, right? So very strict, very stagnant kind of network architecture, and we wanted to have more flexibility, where we got into more VNF or CNF kind of architecture, right? So what is VNF? Virtualized network function, and CNF, which is cloud native network function or containerized network function. So that's what it is. So this is the kind of architecture we are moving in from 4G to the 5G network. Now, if you look at the overall architecture, what we are doing here is it is not really changing in a drastic way. The AMF is kind of replacing MME, SMF is kind of replacing the control plane of HGW and PGW, and UPF is kind of replacing the user plane of the HGW and PGW. PCRF is now replaced with a new node called as PCF, and AUSF and UDM. AUSF and UDM, which are typically taking up the role of HSS. So these are some major architectural changes, but that's not all about 5G. The 5G may look a little more complex with the reference point architecture, but this is the architecture which is just good for eyes. We don't really talk about all these interfaces. The interfaces, what you see here, are not really meant to be discussed. Why I'm saying this? Because all these architectures, all these interfaces will be implemented with something called as service-based architecture, what we are going to see in the next couple of slides. So even though reference point architecture looks very complex, but again, it is not really used extensively because most of our communication will happen over service-based architecture. Now, these are some of the name of the network functions, which includes AMF, AUSF, PCF, etc. We need not to talk about all these network functions here in detail, right? This is what the service-based architecture looks like. Now, if you remember, we have already talked about AMF, SMF, UDM, PCF, etc. And AUSF is also can be considered as a subset of HSS, but it also comes with some new network functions, which includes the NRF, NF repository function, NEF, network exposure function, and NSSF, which is network slice selection function. The UPF is more of a user plane part of it from the HGW and PGW. Interestingly, the boxes what you see here, all these boxes what you see here, they are not really the hardware boxes. They are basically the collection of microservices. That means the AMF and SMF or any other network functions for that matter, they are not really created as a single function, but they are created as a collection of microservices, and they are all hosted in containerized environments. They are all hosted in some kind of containerized environment. All this infrastructure, what you see here, can be built on a single PC or can be built on a COTS hardware. COTS hardware, which is commercially off-the-shelf hardware. So I can implement all these network functions in single piece of hardware with lot of different microservices. This is how the overall architecture looks like when I talk about the 5G core network. Secondly, all these communication, what is happening here, they are not really a telecom or 5G specific protocol. They are all RESTful API communication. So they all do something called as RESTful API communication, which is carried over HTTP2 protocol. So all these communications are happening over HTTP2 protocol, hypertext transfer protocol, right? So they are all communicating with the HTTP2 kind of protocol. However, even this picture, what you see here is not a complete picture. The release 17, the release 17 have up to 28 network functions, 28 network functions with 102 microservices. That means these 28 network functions provides up to 102 microservices. So this is how vast your 5G core network control plane is in release 17. All these details, all these, the functionality of all these network functions, the communication between them, that's what we typically discuss in our program, where we have a specific session talking about each and every network functions, what you see on the screen, and also beyond that. Right. Now, let's move on and start talking about quickly about SBA, service-based architecture stack, and the protocols. Right now, if you look at the overall protocol stack, it is nothing but a TCP IP kind of protocol stack, TCP IP kind of protocol stack. where we are having all the communication in the RESTful API based communication, They all use HTTP2 protocol, which use the HTTP2 methods like put, get, delete, post, update. All the 3GPP specific data is serialized using JSON, which is called a JavaScript object notation, serialization protocol. And overall, if I talk about the communication, they are using HTTP protocols to transport JSON formatted messages in the RESTful API style, right? So basically, we are writing all the 3GPP related information in the YAML format, in the YAML files in JSON format, and then carry that information over HTTP2 protocol. So HTTP2 protocol, which is generally application layer protocol, we are just using that as a protocol to transport our communication from a point A to point B, right? So this is typically how the SBS stack looks like. We can also have some kind of TLS implementation. We have multiple different ways of implementing security in the 5G core network as well. They typically work in two different manner. Either they can work as a subscribe and notify, which is one of the semantics, but in general, they typically work like a producer and consumer, which typically communicates using request and reply kind of messages. So in network functions like AMF, another network functions like SMF, any network functions, any network function can be a consumer and can be a producer. For some services, this can be consumer, this can be producer. For another service, this can be consumer, this can be producer. So the consumer is going to request for some information from the producer, and the producer is going to reply with that particular information, right? So they will be typically giving you some kind of HTTP response codes, which is like 200 OK, 201 created. So they will all communicate by using HTTP and using HTTP response codes. So all the communication happens based on the RESTful API kind of communication. Now, if I talk about the network functions and their services, typically the AMF provides multiple services. So in release 15, AMF provides 4 services, and in release 17, 2 more services were introduced. All these services are listed in technical specification document 23.502. So SMF provides something, AUSF provides something, NRF provides something, PCF, UDM all provide something, some kind of information, some kind of RESTful API communication they provide. And all these things are standardized by 3GPP in the form of Open API 3.0 files, right? So we actually, in our sessions, we actually open up some of these YAML files. We open up all these YAML files. One second. Okay, open up all these YAML files and then we discuss the content of those files, right? So that's, and as I mentioned, this is just a glimpse of it. Overall, there are 102 APIs provided by 28 plus network functions. Now, just to take an example, we have 4 services of AMF, which is NAMF underscore communication, NAMF event exposure, NAMF empty, NAMF location. And these are the different services which are provided by AMF, where communication is one of the main service to communicate with all the network functions. And AMF event exposure is the microservices which will help the AMF to, you know, expose the events like UE reachability, mobility changes. So whenever user is moving from one place to another place or getting from connected to disconnected mode, it can actually update some of the network functions about the UE reachability. MT services, the mobile terminating services to make sure that UE is reachable, and location based services is to get the location of the UE. 2 other services which are not really, which is introduced at the latest stage in release 17, they are related to MBMS services, multimedia broadcast multicast services. Now, if you look at the content of this is the file I was talking about, NAMF communication. If you look at here, This is the one of the NAMF communication protocol. In the left side of it, this is a YAML file, and we are just opening this YAML file with using a smart editor. In the right side of it, you can see the English translation of this particular file, which is typically the file which is having all the information related to this API, which is called as NAMF communication. In our discussion, in our paid course, of course, we discuss all these things pretty much in detail, the structure of these files, and we share these files for the participants to review and look at this information, right? In addition to that, even these four services are not sufficient. So you can't really do everything by using these four services. So what they have done is they have further divided them into multiple service operations. They have divided them into multiple service operations. And these service operations, right? They are typically service operations. These are typically the different parts of the same services. So we normally define this as a API specific resource URI part. What is API specific resource URI part? I will not be able to explain it here, but that is actually the actual content of a RESTful API call, which is happening from one network function to another network function. These service operation, they have two different operation semantics. One is request and response, as we have seen 2, 3 slides earlier. And the other one is subscribe and notify. The other one is subscribe and notify, where you can subscribe for some future information and you can be notified whenever those information happens. In addition to that, it also defines who can be the consumer for this particular service. For example, if you look at the first four service, the service provider is also AMF and the service consumer is also AMF. Service is provided by AMF and service is also consumed by AMF. Both the things are done by AMF only. So AMF also need to communicate with each other whenever they want to transfer the information, transfer the context from one AMF to AMF, then that's where AMF can also communicate to each other. But if you look at some other services, they can be consumed by number of different network functions. So it can be consumed by SMF, PCF, NEF, SMSF, UDM, etc. So there are a lot of different network functions who can consume the services of the AMF, right? So with this, let me pause for a couple of minutes and see if there are any questions in the chat box. Okay, so these were some old answers. Any questions you have till now, please feel free to type that in the chat box and we can take it up before we proceed further. Okay, so Shreya says, what is the difference in UDM in a USF? Shreyas, UDM is the one which actually manages the user subscription data. It doesn't really store it. For that, we have a separate network function called as UDR, Unified Data Repository. That's where it is stored. But UDM is the one who is going to manage it and pass it on to the AMF whenever it is required. AUSF is just used for authentication purpose, right? So it has a very small functionality where it becomes a part of the authentication procedure. And there is a major difference. There is a major difference in how do we really do the authentication in 4G and how do we do the authentication in 5G. And AUSF plays a very important role into that different type of authentication. So authentication is slightly different than 4G and different than 4G in 5G. And AUSF plays an important role in the authentication part of it. So UDM does the data management. AUSF takes care of the authentication services. Any other questions before we continue further? Let me have a look at it. Okay, so Moniji says in SA architecture, SIM needs to be changed required, e.g. as IMSI is replaced by SUPI. Is the CNF deployment is covered in this course? Yes, so let me answer one by one. So Moniji, if you see the SUPI, if you look at the SUPI identity, right, so it has got a field called as SUPI type, which is a 3-bit field. And with 3 bits, we can have values from 0 to 7, 0 to 7, right? So one of the value is IMSI value. Another one is NAI value, which is network access identifier. So IMSI, so we need to understand that SUPI is not replacing IMSI. It is creating as a superset of the different identities, and one of that identity is still the IMSI, right? So IMSI is not really the whole, the whole identity which is used in 5G. So it's actually a added with 3 more bits, which is typically defining the SUPI type, and one of the type of SUPI is going to be IMSI number. Right. So somebody called Pani, he says, is the CNF deployment is covered in this course? Yes, we talk about the how we are going to deploy the 5G core network into the Docker architecture, some kind of cloud. Of course, we don't share the machine, so you need to create all those cloud infrastructure at your own. We will guide you, how to do it for free, how to do it for in the most cost-effective manner. But yes, we will be talking about the deployment of the 5G core network in the course itself. Okay, right. Any other questions before we continue? Any other questions? Okay. If no questions, let's move on and let us talk about these interfaces. Let's talk about these interfaces. N1, N2, N3, and N4 interfaces and protocol. So if you look at this picture, we have the communication happening between the UE and the G node B, which is typically the protocols like MAC layer, RLC layer, PDCP layer, RRC layer for control plane, and STAP layer for the user plane. Even though we have a session talking about all these protocols in our course, we don't really cover all these things in detail. So this is a 5G core course, so we don't really get into the detail. We have a overview course where we talk about the functionality of all these layers. We talk a bit about 5 layer, talking about numerologies, etc. But we don't really cover all these things in a pretty extensive manner. However, the communication between G node B and AMF, which is the N2 interface happening over a NGAP protocol, and the N3 interface, which is happening over GTPU protocol. We talk about all the protocols, procedures related to all these interfaces. In addition to that, we also have an interface between SMF and UPF called as N4 interface, which is both, which is actually the interface to inform the UPF about all the packet detection rules. That's what it is on the N4 interface between the SMF and UPF, right? In addition to that, there is an N1 interface, which is the interface between the user and the AMF and used for NAS communication. NAS communication, which is the known access stratum communication, or NAS communication. Right? So these are the different protocols. If you look at the protocol architecture, right, so you will actually see that all the NGAP communication are carried over SCTP, and all the GTPU communication are carried over UDP related protocol, right? So all these communication, they happen either over SCTP or with the UDP kind of communication. A quick recap on all the terminologies what we use in 4G and 5G. The IMEI in 4G is now replaced with PEI, Permanent Equipment Identity. The MSISDN in 4G is replaced with a new identity called a GPSI. The IMSI number is now not replaced, but created as a superset of identity called a SUPI number, which is also used in its concealed version called as SUKI number. MME is now called as AMF, SGW, PGW control plane are called as SMF, SGW, PGW user plane are called as UPF. The HSS is broken down into UDM, AUSF, and UDR. PCRF is now called as PCF. Bearer is QoS flow. PDN connection is now called as PDU session. The PDN is now renamed with DN or data network. The APNs are called as DNNs or data network name. One important thing we need to note here is even though many of these things are very similar, even though many of these things are very similar, but they are not exactly same. There are significant difference in all these things. So this is just a analogy what we have created. They are not exactly same. Some of these things are very similar. Some of these things are very different as well. It's just a quick comparison what we have created here, right? Now, let us look at a brief procedure of UE registration. As I mentioned in the previous discussion, the initial registration in 4G and 5G are very different. In case of 4G, home network just gives all the content to the widgeted network, and then widgeted network does all the procedures. However, in case of 5G, the final decision of authentication is taken by the home network, and that is where we come with a beautiful role to play by AUSF. In case of 4G, IMSI is sent in clear text during registration. In case of 5G, SUPI is not sent in clear text. It is sent as a SUKI or a concealed identity, which is a one-time entity. So SUKI is not really a continuous identity. It is created every time we have to send it, and it is only used once. So the user, whenever they use create SUKI, they are actually using one second. Somebody is trying to create some issues here. Right, no problem. So Suki is used only one time. Suki is used only one time. The third major difference is during initial registration in 5G, creating a default bearer is mandatory. So you cannot complete the registration. You cannot complete the registration until unless you create a default bearer. However, in 5G, creating a default PDU session is not mandatory. You can just do the registration and leave with it. You can just do the registration and leave with it. So these are some major differences in the architecture of, in the registration of in the 4G network and the 5G network, right? So even though this particular picture doesn't really justify, how do we really look at the registration procedure, but just a very, very high level picture. Generally in our course, this one particular slide is extended into 10 different slides along with the detailed log analysis. Right. But just to give you an overview here, even though registration looks like a simple procedure and single procedure, it can be broken down into 7 or 8 different options depending on what identity shared by UE, where it is going to the same AMF, to the different AMF, whether the AMF knows the user or not, whether the old AMF knows the user or not. Depending on all these different options, there can be 7 or 8 different options available for the UE registration itself, right? But here, whenever user is triggering a registration, it sends some identity. This identity can be SUKI value, can be 5G Kuti value, right? Based on this, the GNodeB does the AMF selection, and based on that, it sends that message to the AMF. What AMF does is AMF, with the help of AUSF, UDM, and UDR, does the AKA authentication. AKA authentication is called as authentication and key agreement. So during this procedure, there will be two things, A and KA. A stands for authentication and KA stands for key agreement, authentication and key agreement, right? So this is exactly what happens between the UE, AMF, AUSF, and UTM. Once that is completed, it also does the NAS security where it will activate the integrity and ciphering protection. These are the keys which are generated during KA or key agreement, right? There is also a context created between between GNodeB and the AMF for a particular user, right? If required, the AMF can also fetch the policies from the PCF, fetch the policies from the PCF. And once that is done, it is going to send the registration completion message and assigning all the IDs, registration area, timers, etc. And you see, interestingly, if you look at this interestingly, this is not really having any communication with the SMF and UPFs. As I mentioned in the previous slide, it is not really mandatory. It is not really mandatory to involve SMF and UPF to do the registration procedure. During our course, we actually talk about all these things pretty much in detail. But in addition to that, we also look at all the protocol logs, where we look at all the protocol information ID, all these different type of communication, right? So we actually talk about the protocol messages going from all these nodes from AMF, NRF, AUSF, UDM, UDR, Gnode B, all these logs we discuss pretty much in detail in our paid course. So I'll not going to talk about this here, but that's generally we talk about in our course, right? The other procedure, which is the PDU session establishment, that is where we will have some role to play between of SMF and UPF. And this is also a brief. Now, just for your understanding, for registration procedure, AMFs become the anchor node. That means the registration is the responsibility of the AMF. Registration is the responsibility of the AMF. Just like that, for PDU session procedure, SMF becomes the anchor node. Now, AMF, when it is getting a PDU session establishment request from the user, it is going to pass it on to SMF, and then SMF is going to interact with PCF, with the UDM, with the UPF to do the needful. And finally, once all these communications are completed, the SMF is going to inform the AMF, and AMF is going to inform the G node B, and G node B is going to inform the user. So for the PDU session procedures, the SMF becomes the anchor node. So if somebody asks you who is managing the quality of service, of course, the quality of service policies, they come from PCF, but the anchor point for your managing complete end-to-end quality of service is the SMF, because SMF is the one who is going to share this information to UPF, to the G node B, and to the user. So that's where, so similar to initial registration, we also do log analysis for PDU session procedure as well. Right. Now, that's a quick introduction. And as I mentioned, I am starting another session starting next week, right, where we actually talk about where we typically, cover all these topics pretty much in detail. But before I start talking about it, it is pretty okay. It is pretty okay if you are not interested in the paid course. Feel free to drop from this discussion. Feel free to drop from this discussion. I don't really want you to force and listen to the course what I'm offering, right? So I will be talking about for another 10 minutes about that course, right? So there is 4 5 questions. Is deployment based on open 5Gs, free 5GC? We have different type of options, and you can choose. We typically inform you to do all these different kind of configurations, but you can choose whatever you want to use. How REN selects AMF configuration discovery. So there are multiple different hierarchies which are created for the AMF selections, and we generally talk. Authentication is done through NAS protocol or RRC. Shares authentication is the responsibility of the core network, and RRC is just between UE and G node B. So it is carried by RRC, but the protocol involved for the authentication is NAS protocol. Authentication is the NAS layer functionality, not the RRC layer functionality. Any other questions before I talk about a little bit about my paid course, what we are starting next week? Any questions? Any technical questions not related to the course that we can take later? Any technical questions? Okay, so do we get lab 5GS? I'm not sure if you understood that. I told that we build the lab, but I don't give you the access to the lab. So we will enable you to build your own labs and use it for future, but we don't really build the lab at our end and give you the labs, right? So because there is a lot of cloud cost associated with it, and generally that goes around 5,000 rupees for a week, right? So that is something what we cannot afford in this particular course. However, we are coming up with a platform where we also give you the lab access and in a self-paced manner, but that's something different. Right? So I'll not talk about that here. Right. So we don't provide you the lab, but we enable you to build your own labs and use it for future. Any other questions? Okay, if no questions, let me see this here. Okay, let me just talk about the course, what I'm talking about. Right. So today was the first session what we had here. And This session starts next week. So this is 28th June. Next Saturday it will start. The timing will be 11 a.m. to 12 p.m. I also got a lot of requests from people in US and Africa, in Europe. Before you join this course, just make sure it aligns with your timing, right? Because this is the Indian Standard Time, which is plus GMT plus 5:30. So if you are trying to attend this course, please make sure you check the timing. Please make sure you check the timing and then only pay for this course, then only join this course. So it may not be possible for somebody in US or maybe some part of Europe to join this course. It may be a little too early for them. Some people have also requested to do it on other different times. As of now, there are no plans. This is the only batch we are starting from 11 to 12 or 12 to 1, right? So we will not be able to have timing at different timings for different students, right? Now, what are the things we are going to cover in this particular courses? We'll start with the course introduction, which is like the things what we have talked today. Talking about wireless fundamentals, where we talk about TDM, FDM, TDD, FDD, OFDMA, SCFDMA at a very, very high level. And then getting into, before jumping onto 5G, we also talk about 3GPP standardization and the evolution which has happened from 2G to 3G to 4G, right? In addition to that, what we start with our 5G overview discussion, where we talk about the principles and the motivation behind 5G, a quick session on 5G NR and Open RAN, which is not going to be detailed session, just a quick session. And then we jump on to the complete detail of 5G core network architecture and the network functions around it, right? We also get, after talking about network functions, we talk about all protocols and procedures, which is going to be a detailed discussion with all the protocol logs what we are going to have, right? The cloud native overview, where we talk about, so some people ask, okay, we want to attend only the Docker and Kubernetes course. So we use Docker and Docker kind of technologies to build our labs, but we don't really talk about all these things in detail. So we also have a quick overview session on the cloud native architecture as well. We talk about 5G lab setups and hands-on. So typically this will allow you to set up your own labs and use those labs in your computer or in your cloud resources. How to do it, what to do it. We will be talking about complete end-to-end discussion around it. The 5G security, we will talking about 5G network slicing, MEC, orchestration, etc. So these are going to be some of the advanced topics related to 5G core. And finally, we have a session on AI in telecom. Of course, we have a separate course on AI in telecom if you're interested, but this is going to be a very quick session on AI in telecom, right? And then we have beyond 5G and towards 6G network. What are the changes happening when we are moving from release 15 to 16 to 17, and we are already heading towards release 21, which is going to be the first commercial release for 6G network, right? So now what you get in this course, almost 20 plus hours of online live session by experts. In addition to that, you will be having detailed protocol analysis with logs. All the log files, all the API files will be shared with you, spread over 16 weeks, mostly on weekends, 1 hour each on Saturdays and Sundays. Session recording will be available for 6 months on our web and application. Even after course completion, if you have some doubts, if you have any questions, we can get on a one-to-one session for a support session. The labs we will not be providing you, but we will be enabling you to build your labs and use it forever. We will be sharing a lot of reference material, resume review and interview preparation. This is not really delivered as a session, but if you're interested and want to know more about it, we can really talk about it. Job assistance in terms of sharing your profile in any known vacancies what we get. We don't guarantee any jobs, we don't guarantee any placements, etc. So just wanted to make that clear because many people have this question, right? The typical fee for this course is around 25,000 rupees, which is 2499, approximately 250 USD. And now, just for inaugural offer, we are offering this is around in 19,999, which is approximately 20,000 rupees plus taxes. We will be imposing 18% GST and some platform charges on top of it. This has to be paid if you want to attend the classes starting next week, right? But if after the next week session, and if you're not happy with that, we can also refund it. within 10 days of delivery if not satisfied with the course. If you are joining with 2